Kia ora Year 10. Here is a short video going over what we've done in class this week on working with powers in algebra. So I'm going to start with some very straightforward problems that just have variables, so just the letters, and then I'm going to mix them up a little bit more with numbers and several letters. Most of the skills in this video are at the achieved skills level in Year 10. So number 1 is x to the power of 5 times x squared. When we start out doing algebra, we could write this out like this. X to the power of 5 is x times x times x times x times x times x. So you can see that that will work out to be x to the power of 7. That was pretty tedious, and we quickly figured out a rule that when we had the same base, x, we could add the powers. So 5 plus 2 equals 7. We also talked in class about how this was a multiplication sign, and this, the curly x, was a variable. So it could represent any number. Okay, on to number 2, we can do the same kind of thing. X to the power of 5 is equal to x times x times x times x times x divided by x times x. Using our knowledge, we can divide the numerator and denominator by x. So we can write that like this. Okay, and we're left with x cubed. The last one, x to the power of 5, is then squared. So we have x times x times x times x times x. And we want all of that times itself, which is what squared means. So that's x to the power of 10. What we're going to do on the next slide is look at the rules we figured out for working with powers, and there are 4 of them. When we have a to the power of p times a to the power of q, we just add the powers. Okay, on the last slide, we had x to the power of 5 times x squared equals x to the power of 7. I'll put my examples down here. When we divide powers, we have a to the power of p over a to the power of q. If we've got the same base, we subtract the powers. So x to the power of 5 over x squared worked out to be x cubed. When I have one power, we'll write it as a to the power of m, to another power, we multiply the powers. So the example from the first slide, x to the power of 5 squared equals x to the power of 10. And lastly, one that we haven't looked at yet, is anything to the power of 0 is defined to be 1. We'll take more of a look at where that comes from and how that fits into a big pattern in class. Okay, but for now all you need to know is that anything to the power of 0 is 1. Let's look at some examples for you to try now. Okay, so these 4 examples mix in numbers with our variables, and we call the number sitting next to a variable the coefficient of that variable. Okay, what we do with numbers is we work out the number part first. Okay, so this first one here is going to be 6 9s are 54. Now I've got x squared times x to the power of 6, so that's x to the power of 8, and I've got y squared. Right, notice that I can't mix up these two anymore because this one has a base of x and this one has a base of y. I can't combine those unless they've got the same base. And the next one, first I simplify 21 over 3. So that works out to be 7. I divide through by a common factor of 3. And I get 7. And now it's going to be x to the power of 9 minus x to the power of 9 minus 6, so x to the power of 3. And I don't actually need that fraction line anymore, so we'll get rid of that. Okay, so the answer here is simply 7x cubed. Right, we'll get rid of this. This is a little bit too messy for me. So we'll clean that up. Okay, that's gone. Okay, so one more time we do the numbers first, and then we work with our variables using our power rules. In the next one, it's similar but different. I have a common factor of 3, so 3 over 21 works out to be 1 over 7. So I have 7 here and 1 here. I have x to the power of 6 up here, but x to the power of 9 down here. So if I divide x to the power of 6 on the numerator and on the denominator, I'm left with x cubed down here. Lastly, this one here will equal, well, let's have a look, 5x to the power of 4 times itself 3 times. Now I know how to do the manipulation of the x part of this. Using my third rule, this will be x to the power of 12. But what do I do with the 5? Well, it's just going to be 5 times 5 times 5. 5 cubed, which is 125. Okay, be really careful of that. It's a very common mistake when you're starting algebra to say 5 times 3. But it doesn't work. Okay, so it's 5 to the power of 3, but x to the power of 4 times 3. So those are a little tricky. You need to do plenty of practice to make them feel automatic. On the next slide, we're going to do some examples in your book. Okay, I want you to pause the video and have a go at doing these in your book, and then I'm going to quickly go through the answers. Alright, here are the answers. Number 1, add the powers, y to the power of 11. Number 2, 2 to the power of 3 is 8. And z to the power of 3 3s are 9. Number 3, deal with the numbers first. 50 over 120 is 5/12. I have a to the power of 7 over a to the power of 4, so I'm left with a cubed in the numerator. Number 4, work out the numbers first. 4 over 16 is 1 over 4. X cubed divided by x to the power of 8 is 1 over x to the power of 5. Number 5, 16 over 24. Well, numbers first. I have a common factor of 8. So 16 over 24 is 2/3. So I have 2/3. I have 7 up here and 11 down here. So I'm left with x to the power of 4 down here. Next one. Numbers first. 45 over 50. Divide through my common factor of 5. 9 over 10. So this one will be 9/10. Now we need to do this in 2 steps. So that's okay, so we've got x, whoops, what's happened there? And we've got x to the power of 6 over x to the power of 7. So we're not finished yet. That will be 9/10. And the x will be in the denominator, so it'll be 9 divided by 10x. Right, number 7 has got numbers, y's and z's, so we deal with each in its turn. So 4 over 8 is 1/2. I'll just change pen colour, make it a bit easier. So 1/2. I've got y squared over y, so that's y in the numerator. And I've got z over z squared. So that's an invisible power 1 there, just as it is here. So this is z here. Now I've got 1y over 2z. Remember, 1s are often invisible in algebra, so it's just y over 2z. Right, number 8, numbers first, 3/4. I've got x squared here, x to the 4 here, so I have x squared here, and I have y squared here. Okay, so that's those 8 examples. So mark those in your book now, and I'll take a look at how many of those you got right. On to the next slide. Right, if you want to do more practice for this, which you should be doing, the homework is beta, page 36, and you can do exercises 805, there's the very easy ones on these, and then 806 on the 4 rules, and then 807 as well. 808 with square roots we haven't done yet, but I'll be working on that in class with you this week. Thanks for watching.